I am recording this. So, okay. Before I start showing you the software, a couple of quick questions. How do you currently apply any tolerances? Do you apply all the tolerances on the model using PMI, or do you actually apply it in the draft? How is it performed in your company?
It's quite difficult for me. Um, it depends on user. I will say we try to get the BMI, or we use actually BMI.
Okay. And everybody, all the users, they do their own analysis, hand calculations, or Excel, Microsoft Excel. That's what they use currently to perform any kind of analysis.
Yes.
Okay.
Yeah.
All right, then what I'll show you is how the program works with SolidEdge and how the functionality. I'll first explain the interface, and then I will go into the software functionality and walk you through the process or the workflow. Both of you, are you from engineering, or are you from one of you, is any of you from quality or manufacturing side?
No, I'm mechanical engineer.
Okay. The very first step is to get started with your SolidEdge. You can open a SolidEdge assembly, you can open a SolidEdge component or a draft, and you can export data from any of these into Sigmund, and I'll show you all the three options. I can open a simple component here, or assembly. There has three components: a block with the opening, then you got another a block here, and then there's another simple component. So those are just the three pieces of this assembly. The first thing that the user would do is I can go in and say export data to SigmundEdge, and once when I click on this option, what it does is software brings in automatically all the information from the assembly into Sigmund. So as I expand this feature tree, now you'll see that each of these components and the corresponding dimensions and tolerances. Now this information is coming from the PMI data or from the sketch dimensions, extruded dimensions, or the variables that you have defined. So the user can define these on the SolidEdge model, and then it will automatically bring this information in. And when I click on each of these, you'll see on the SolidEdge side, it highlights and shows me all these components. So it is always associative. We are not in the same environment as SolidEdge. However, it still is associative to SolidEdge. So let's say if I open any of these components here. So when I open any of these parts, so you can see all the dimensions and tolerances that are defined on the model. And when I click on any of these, it highlights and shows it to me on the model on the left. So when I'm clicking on any of these dimensions here, you see it's highlighting and bringing it up on my left hand side in SolidEdge. So all these tolerances are associated with solid edge, Sigmund and solid edge. Even though we have a split screen, they still are continuously associated. So I can export from an assembly, I can export from a component, I can also export from a draft. So I can go in to my draft, go into my add-ins, and I can say export data to SigmundEdge. And what that does when I do that is it brings the draft, and as I click on these dimensions, you see them highlighting correspondingly in the solid edge draft as well. You're able to notice that? Let me know if you're able to see it. Okay so far?
Yes.
Okay. Let us say if you have no information on the model at all, there is no tolerances, then you also have the option of exporting non-tolerance dimensions using default title block. 1 decimal place, 2 decimal place, 3 decimal places. You have the option to export this. So if there is no tolerance or no on any of the dimensions, then as a starting point I can use this option to export data, and later on as I have more actual information on the draft or on the model, I can update it automatically. So that is the first step, is to export data from solid edge into Sigmund. Now I'll explain the interface. So what you are seeing right now is the SigmundEdge interface. On the left hand side you see all the components, the feature tree and all the components. On the bottom you have all your objectives. So every objective or every study that you are interested in, different gaps that you are interested in, clearances, height, measurement. So any objectives that you are interested in, those will be studied or conducted in this region, and then you can save them. So when I have a study, for example, I'll show you how it is created, but first let me explain and then I'll come back to it. So when I have a study, what the top box you see is currently the main objective that is being studied or analyzed. And these boxes are individual tolerances that will have an impact on this particular study. So that is how the structure looks. So you got a 3-window environment with all the tolerances, then the studies on the bottom left, and the actual structure of the study and all the reports will show up in this side, on the right side where my current cursor is. So that's how the interface is laid out. So once you export data, the next step in the process would be to actually define your objectives and say which ones do you want to perform analysis on. And to do that, let me switch back. Let's define a couple of objectives on this. Simple example. So I'll first start with let us say I want to evaluate this gap from that surface to this. So this is the gap that I'm interested in checking to see how much gap will I have between these two components. And based on the way the components are dimensioned and assembled, I have from this surface to this surface. So it is essentially the width of this minus this width and this width. So those are the three tolerances that would have an impact on this particular objective. So the way the user goes about creating this, I go into my build objective and say I want to create a new study. And all it creates at this point is just a objective box wherein I can go and say this is one of your objectives. I can define the type of objective, gap, clearance, flush, height, engagement, alignment, whatever objective you are interested in looking at. And then you can also quantify your requirement. If you know what is the target you're trying to achieve, you can specify that particular target in this region where I can quantify saying this has to be within plus or minus 1 millimeter, plus or minus half a millimeter. So you can specify what is the target that you're trying to achieve. So I can go in and specify, let's say, plus or minus half a millimeter. So I qualify and then I quantify my objective. Once I do that, the next step in the process is to actually create the study itself. That's where I can go into each component. I have all the components and the corresponding tolerances for each of these. So I can simply drag and drop these tolerances from the feature tree as I'm showing you. So the first one is the hinge opening. That's the first tolerance. Second one is on the shim component, the bigger block. And the last one is on the small block, smaller shim. And when you actually open any of these, it tells me where is this coming from, name, type of tolerance. We support all the different geometric tolerances, and in addition you've got any plus minus linear alternate dimensions, and you also see two additional types of tolerances that are not inside your CAD program. Those are float and any custom tolerances. Float is mostly an assembly process variation. For example, if you have a hole and a pin, and then if the pin is and the hole are not a press fit, if it's a clearance fit, then in that case the pin can move around. So that is going to cause some clearance where things can float. That's float. That's how we define it inside Sigmund. Custom tolerance refers to any tolerance relative to assembly process variation. For example, if you're using a fixture, or if you're using adhesive or a glue or a weld or welding, for example, any of those. So those are part of the actual assembly process variation. Those all could be added inside the program. And you get your nominal from your CAD automatically, and the data from your SolidEdge, the tolerance information, is automatically coming into the roll-up column here that you are seeing. I'll explain roll down a little later. So roll-up is where you're getting all the data from. And you also see an option of getting data from file. This can be used if you want to read the actual manufacturing data. If you want to use the actual inspection data and read that data, then I cannot do that as well. So that's what this option is for here. By default, the variation range is set at a range of 6 sigma, which is a CPK of 1. That is a default setting which user can change. So step 1 is to bring in the data from SolidEdge. Now step 2 in the process is to create the objective and create the actual vector loop, where you simply drag and drop, and as you're dragging and dropping, you can actually, when you click on these, it highlights and shows it to me in the actual model. So when you are selecting these, the user can easily identify which of these tolerances. So if I click on any of these, then it highlights and shows me which tolerance is that corresponding to, so I know which one to grab and drag and drop in my study, which one to use as I am selecting through. So this is the next step, is to create the actual vector loop which you are seeing in front of your screen. Once you have this, the next step in the process is to actually do the analysis. And we have two methods in which the analysis can be performed. One is a roll-up approach. That's what you're seeing on your screen right now, is where I know all my tolerances. All these boxes are known and this is unknown. The top box is unknown. This is what most of the people are used to. Bottom-up roll-up approach. Add all the tolerances and see where you are. The other method that we also provide in Sigmund is a roll down, or a design for Six Sigma top down. This is where I can specify my requirement on the top. So I am giving you a design specification saying it has to be plus or minus 0.5 millimeter. And then the software can determine what tolerances are required on all these different features to meet that particular design requirement. So that is the roll down method. So there are two methods. One is the roll up, which most of you are familiar with, and the other which is unique inside Sigmund is a roll down. And when you're doing roll down, initially the software would allocate tolerances equally among all the components to meet this objective. So when I do a roll down, you can see it allocates tolerances equally between all of them. However, in real life, that may not be the case. One of these might be purchased part. You might be buying from a supplier. So what you're going to get on this is what you're going to get. Or it might be manufactured on an existing line with known tools and published capability. So you cannot force a different value on that. So in those cases, I can lock them to a certain value. For example, in this case, let's say I have this option where I can lock it, let the purchased part. So I can lock this if that's what my manufacturing tells me, or the supplier tells me that I'm going to give you plus or minus 0.1 millimeter. I can lock it to that value. Now you see a small lock icon indicating that this is fixed tolerance, and these two have changed. Also in real life, not all processes are of the same cost. Not all materials are of the same cost in terms of availability of processing techniques. So some might be more expensive than others. Now let's say, just for discussion, that this is using an expensive process, manufacturing process. You see the option of weight. This is similar to costing. Let's say this is 3 times more expensive than this process used to manufacture this particular component. So when I do that, now you see that the software automatically redistributed tolerances, and it drives precision to where it's most cost effective while still meeting your objective up above. It always tries to see what tolerances you need based on the conditions that you're applying, such that it meets this design target. So how to use that information? How can I use that particular information? To use that, the way you are going to be using that is, I can compare this from a roll up and roll downs, both of these, as roll up is what you're capable of manufacturing, roll down is what you're trying to achieve. So that is the difference between roll up and roll down, and I can use this as a comparison when I run my analysis. And to actually run the analysis, it's as simple as selecting these different options. There are 5 techniques that are supported. Worst case, which is min max, RSS, root sum square, root mean square, modified RSS with a safety factor, process centering, if you know how a particular process follows, if there is any mean shift happening, for example, because of gravity, process might be shifting, or tool wear, for example, if you consider drill bits, as you're drilling, your drill bit is going to wear out, that will cause a mean shift. Or if you're using a punch, stamping, high speed stamping, then a punch is going to wear out. So what happens in that case is, it's not to do with the tolerance, but the process mean shift, where things start shifting to one side or the other. So how do I consider that? And also Monte Carlo simulation with different distribution types. If you know what your process follows, then we can more accurately use that, as you are seeing here. If you don't know what your process follows, but if your quality department has been taking SPC data, then there is an option of user input right here, where you can read in the actual data from your manufacturing or from your inspection or quality, and use that data to determine what is the best distribution type, or just use the data to run the simulation. And to do the actual analysis, it's as simple as selecting the analysis technique, worst case, and the method. Up and down arrows signify roll up and roll down. To switch from one study type to the other, let's say I've done this study in worst case. If I just want to switch from one to the other, all I do is select the analysis technique and the method. So you see modified RSS. So switching from one analysis to the other is as easy as clicking these buttons here. I can duplicate the same study to look at different conditions. So I'm making a copy of this. So if I want to do the same study under RSS, it's just a comparison to see where am I. So now you will see the same in the result here. Your nominal is 0.5 millimeter and plus 0.3 and negative 0.4. So that's what is telling you that's where you're going to be. if you look at it from an RSS. And the same study in worst case. Oh, okay. So if I do this in worst case, now you see in worst case you have got 0.5 plus 0.55 and negative 0.65. So the comparison between roll up and roll down tells me what you're capable of versus what you actually need to meet that particular requirement. So when I open one of these here, let's say, you can compare and see. So in these areas, it is telling me in these two, between these two, your comparison roll up, roll down. It is telling me roll down what you actually require is almost plus or minus 0.46. What you currently have is plus zero point 0.1 and negative zero point 0.2. So you have an option where you can increase that. You can open that tolerance up on this particular feature. And on this one, it is telling you that you will have to change this from plus or minus zero point 0.2 to plus or minus 0.15. So here it is asking you to reduce the tolerance, and here it is asking you to increase the tolerance. So that's how it tells you what tolerances you actually require to meet a certain objective. So when the user is performing analysis, you will be doing both roll up and roll down, not just one, because you want to determine where you end up and as well as what do you need to optimize. So a comparison between your roll up and roll down can also be seen in a histogram. And what this is telling you, so your requirement LSL, USL, maximum gap of 1 millimeter and minimum gap of 0. Right now you have an interference of 0.15. So it is telling you how much out of spec you are. And this is all the areas where you're having issues on your histogram, as you can see. And if you want to know what is causing that, then you have a sensitivity report that tells me which input variables are impacting, what are the ones that have the most significant impact. So this is getting,
Hello.
yeah,
It's we have some environment noise.
um,
Hello.
yes, can you hear me?
Now it's better. Thank you.
Oh, okay. Yeah, previously I was hearing some noise. I didn't know if it was on your end. So I'm getting that noise again. Okay.
Okay. Is this your fan or what? You're sitting in the wash machine?
I no, I am inside a conference room.
Okay.
I am inside a conference room. There's no noise here.
Okay. So
So this tells me, the sensitivity report tells me what input variables are significantly impacting the output, which is the gap that we are looking at, and tells me which ones to focus on. Obviously, you look at the first on the extreme left. Well, this is a purchased part, so not much can be done. So in that way, I'll move on to the next two contributors to see if we can do anything in terms of optimizing these variables. So you have got the sensitivity report both for roll up and roll down, telling me which tolerances to look at for design optimization. And you also have the Monte Carlo histogram. So when you look at a Monte Carlo histogram, it gives you more statistics, more number of samples that you're building, and it tells me where you are relative to that particular objective. So Initially, you're doing a design evaluation. That's what you're doing. And then you look at sensitivity report to see how to optimize, which variables to look at for design optimization purpose. Are we clear so far? Bless you. So once you have this, so in terms of, as a recap, I'll go through. So exporting data, then creating an objective, and the way you would go about is drag and drop tolerances from your feature tree and create a vector loop. So that's how you drag and drop these tolerances and create the structure of the study. And then you select the analysis type, and you create the study loop. You select the method and do the analysis to determine where you are. So that's how for each objective. So depending on how many other objectives you have on each of these, I can go into every specific objective, and users can simply drag and drop tolerances from the feature tree. And even if you're using GDNT, so let's say if I'm using GDNT to create, so I can have a study that is using position, perpendicularity, flatness, surface profile, and also I can use any tolerance, plus minus tolerance, and create the study itself. I can create tolerances on the fly. I can say if I want to create any tolerance inside Sigmund, user has the option to create any of those tolerances. Let's say hole and pin. I can create any custom tolerances. I can create subassembly tolerances or subnodes. The reason this is useful is to create multiple levels of study. So if I'm going to do a study, something along like this, then I have the option if I want to create multiple levels of study. So you can also do that. You also have that flexibility in terms of creating the actual study in this manner as well. So even if you're using any GDNT or if you're using custom tolerances, assembly floats, and plus minus dimension, I can have a mixed steady type and create something like a vector loop along this manner and perform the analysis. So far we have done the study looking at trying to see where are we, and the next step in the process is to actually do an optimization to determine what tolerances are actually required to meet a certain objective. So if you want to do a design optimization, then there is something, a very powerful feature inside Sigmund, which does automatic optimization of all tolerances for you. And The way that goes in, let's say, if you want to create any of the study, and it is, can you hear me?
Yes.
Okay. If you are using a particular tolerance in many areas, and you will notice that it will have a different value depending on where it is being used, and because the vector loop is different, the tolerances and the conditions are different. For example, look at this hinge opening. In the roll down, in this particular example, it is having a tolerance of plus or minus 0.3. If I look at the same in a different study, here you see it is using a value of plus or minus 0.42. This is in roll down, where SigmundEdge is telling you what tolerances you need. So in both these cases, it's using a different tolerance because it makes sense. The requirement is different, the variables in the loop are different. If I look at a different study again, in this particular scenario, if you look at this one, you see that it is using a value of plus or minus 0.9. So it is telling me that to meet this requirement, I need plus or minus 0.9. So depending on where it is used, depending on objective, it takes in a different value. So Sigmund is trying to tell you that to meet this one, I need this tolerance. But in real life, I can only have one unique tolerance to meet all the objectives or all the requirements simultaneously. So how do I do that? So when we do this optimization here, when we click on optimize, SigmundEdge automatically goes through your entire model, determines a unique optimum tolerance that will satisfy all the objectives, not just one, but all the objectives. And when you look at this tree structure here on your left, you see some of these tolerances have a box around them. So all these tolerances that have a box around them, these all have been optimized. And when you look at the same tolerance, now in any of the study, you will notice that it has the same value in all the studies, plus or minus 0.3, plus or minus 0.3, plus or minus zero point 0.3. So it automatically goes through and determines a unique optimum tolerance, not only on that particular variable, but all the others are also optimized. And it selects and it puts this in a, so when you look at your optimization report, it tells me all those tolerances that have been optimized before and after optimization. And as you're looking at this, you can notice that you have got different study types and different methods. Some are worst case, some are RSS. I could also do some of these in modified RSS just to make it much more interesting. So I can select, let's say, just to make it different, and then I can do my optimization again. So some are worst case, some are RSS, modified RSS, and the software is intelligent enough to handle all those, and it tells me before and after optimization for all these tolerances what it is and where it can go to. So all these areas, it gives me tolerances for min and max conditions. So this is the first one was for all the tolerances, and this is for min max tolerances where they need to be. So you can look and see this is where it was, this is what it needs to be. And it specifically puts tolerances where it has increased my tolerances. These are all the tolerances that have increased and how much have they increased. It also tells me tolerances that have decreased and how much have these tolerances decreased. This is where it was, this is what it needs to be. So areas where you could open up tolerances and areas where you may have to tighten things up. And after it does this optimization, user can automatically go in and say update to solid edge. And when you click on this, automatically all this data is written back to your solid edge. So your model is updated or even your graphs are updated. So if you're none asking what is being updated, then you can just look at this report. This is the report that tells you what is being changed. This is what it was previously, and this after optimization, this is the tolerance you have. So that's what is going to be returned back to your solid edge. It's always associated and integrated with solid edge. Even if you are having any changes or updates in solid edge, all the user needs to do is just click on the update data. So if there are any changes made in solid edge, I can just click on this update and automatically all the data is updated in your CAD. So let's say if one of these, if I make a change in one of these, in this case, let's pick one of these. So let's say I just change that in solid edge. So I'm just saving it. I made the change. I go in and import data. And once I do that, so I went in and changed that. This is what was changed. And you see that once I clicked on the update, this is the data that was changed. It automatically brought that information in. Now I can change it here and also update. So let's say if I change this here, so I'm making a change inside solid edge. So I made a change on this tolerance. Let's say I want a range of 1. When you have that, so that is, in this case you're seeing it here, 0.6742, 5 plus or minus 0.67. So even when you go back and update data to solid edge, the optimized data that we had used, when I click on this, it goes in and updates my solid edge data with the new values or the optimized values that we have. Well, that's the optimized value that we have, 5 plus or minus 0.674. That's what it is using to go back and write the optimized values inside SolidEdge. One of the most important things why you're doing this is essentially to determine on every component what features are most significant, what features are most important on a particular component. When you're going to tell your manufacturing, you want to know. So I can select any part here, and the software has something called as an SPC report. And what this is telling me is a statistical process control, and on this particular feature, on this particular component, what features are most significant. So I can select any component and I can ask it to generate an SPC report telling me that these are areas that are most important on this particular part. This is where you get your ROI, or the bang for your buck, because these are areas that are most significant on this particular component relative to meeting all the requirements simultaneously. So this is where I can justify spending more money if I have to. This is where I can justify having them put on a CMM queue and taking variable data. These are also areas where you can ask your manufacturing to have a better control. They'll come back and say, okay, that's an extra hit, extra gate, an extra machining step, something that will cost you money. Inversely, I have a cost savings report, and what this does is the opposite of SPC. SPC tells you what's most important on a part. Those are areas that need to be in your quality and inspection. Cost savings tells you the opposite, telling what features on a component are least significant. These are areas where you can save money in one of two ways. I can save money on a component for the life of the product by making sure I do not use expensive manufacturing techniques or processes on these areas. I can also save money on a component for the life of the program by making sure that I do not have these in my quality or inspection. I don't want to check things that don't really matter. I don't want to spend a lot of man and machine hours checking and inspecting features on a component that have no impact on my complete of my final product's quality or performance. This is done objectively and scientifically as opposed to guesswork. And if you notice, when I'm doing this SPC and cost saving, you also have the opportunity to put a relative weight on these objectives. Not all objectives are of the same importance. Some might be more critical than others. So I can put a relative importance even on the objectives. So not only are you actually rating, you have the option where I can put a relative weight on these objectives. I'm arbitrarily selecting here. So I can put a weight on these and then use that information as well when performing my analysis in the optimization. So I can select any part here, and for each component it will generate my SPC and cost savings report. So these are the two reports which are probably the most value add of the software, is essentially these two, because what they're telling you is what features on a part are most important that you need to monitor, control, and be inspect, and also what features on a component are least important, where I can save money by using less expensive processing, and where I can also save money in the quality program by making sure I'm not checking all these areas as part of my inspection. Another thing that is more often used is in terms of changing and keeping up, trying to stay updated with all your analysis. The advantage of Sigmund is you only do the analysis the first time when you are setting up the model. Any changes or updates to your SolidEdge, all the user needs to do is just click on File, Update Data, and this analysis or studies are performed automatically. I don't have to manually go in and do the studies again. Just updating data, it will automatically update your data And in addition to that, it also runs all the analysis and tells you if those changes you have made caused any issue. I'll intentionally cause an issue here just to show you how it will graphically show me the problem. Let's say I'm going to intentionally cause a problem, and when I do this, you notice that 4 of these studies here have turned into red, and you see there's an error in allocation of tolerances. What that is telling me is if I make that design change or tolerance change, I am going to have a build issue in all these areas. And when I click on any of these, you'll notice that some of the tolerances have gone to zeros, as you are seeing here. Or sometimes it will go and give you a tolerance of 0.0001 or 0.002, which means to tell that it's very much difficult to achieve that. So your design is too sensitive. So when it goes to values like that, it is early on indication that you're going to have an issue. You don't want to make those design changes, or you have to consider making a nominal design change or change your dimensioning scheme trying to reduce the number of variables. So that is an early on indication before you do any changes or any what ifs. And there are more what ifs that you can also do here, where I can select any given tolerance, and before anybody comes and asks you, hey, can you make this change? You have the option where I can select the tolerance impact or a summary report. So any given tolerance you can select in the entire list, and it tells me where that particular tolerance is used and where it is impacting. So if there is something in this particular situation, I can pick a given tolerance and say, this is going to impact me in all these different areas, and it has a significant impact. So let's say somebody comes to you and says, hey, can you make this change? In this case, I would tell them that no, I cannot, because if I make that change, I'm going to have issues and it will have significant impact on all these areas. Maybe some other tolerance, if I selected this, it says that there is no impact of this particular tolerance anywhere. So in this case, I can increase this by 500% and it's not going to make any difference because it does not impact me anywhere. Maybe some other tolerance, if you select any given tolerance in this entire list that I'm using here, as I'm selecting, it tells me where it impacts. So for each tolerance, you have a tolerance impact or a summary report telling me where that particular tolerance is used and how is it impacting. So before you make a change, you can quickly look it up and see if you can allow that change. If somebody wants to make a change on this, then you will say probably I won't be able to because it affects me on one of the objectives. You also have something more from a management summary report, and what this is telling me is a complete model snapshot, and I can color code and monitor this in terms of percent out of spec, CPM, CP or CPK. So let's say in this case I'm using something as a color coding scheme using percentage out of spec, red, green, yellow. So I can color code this. Let me make it a little red at least. So I have, for each of the objectives, there are 5 objectives that I'm studying. Defined, qualified them. I have quantified, telling what is the requirement I'm trying to meet and where am I relative to meeting that requirement. And red, green, yellow color status that you have. And what we try to tell all our clients is to make sure that you turn them into green before you release your design, because that will give you the confidence or validation that yes, I can go into production knowing that all my parts and components will assemble, and do so by meeting all the build or requirements, the quality performance requirements or design specifications that you have. So it's a simultaneous requirement of meeting all the quality objectives and also having all the parts going together. And all these reports that you're looking at, any of these reports that I've shown you, every one of this report, I can email them, or I can, as I'm showing you here, I can export each of these. I can email them as pictures. So if somebody wants to just look at them, you have lots of flexibility. Any Microsoft or Adobe applications, you can share this data. You can share it even in terms of your HTML or pictures. You can export this data into a text file, or you can keep on adding. Let's say, for example, one of the engineers has done this particular study on their subassembly, and you want to import another subassembly. That's very simple. Let me show you that aspect as well. Let's say I want to open a different example here, and I want to combine these. So let's say I have got another simple example here. File. It asks me if I want to add to the same model, and I say yes. So now I've got this particular example. I can append it. So all coming from the another subassembly, or I can even import a model. So if I'm importing a file from a different subassembly, so these are already studies that were performed on the previous example. Sorry. And at least if it doesn't crash at least once, then the demo doesn't work. So in this case, I can import. So I can import studies and models from a completely different model, and you'll still get the studies that were performed on that particular example also from. So you can see all these studies that were done on this particular subassembly. This is just a different example. And then studies from the shim example that I was showing you. So you can get import and keep on adding or appending files. So in that way, it's extremely flexible, where you're not restricting people in terms of when you're splitting up a big large assembly, and there are many people in your team working with. Let's say you've got 5 people working on different sub-assemblies. Everybody can work on their own, and the system integration level, where you don't have to recreate any of these. All studies are there. I can just keep on appending or adding those and build a list of studies. And some of these, there is no requirement that everything has to be coming from a draft or everything has to be coming from an assembly. So if there are people that are comfortable using draft for creating tolerances, I can export from the draft. I can export from the assembly. So you do have an option in terms of making sure that there is flexibility when using the program. The functionality will remain the same. It doesn't matter if you're bringing information from assembly using PMI or from the draft. So either ways you can get tolerances information from solid edge into Sigmund and then go back and write this data back. So it's always integrated with solid edge. Uh, all that you have got is a different screen, but if you're using dual monitors, then I can always have solid edge on one side and Sigmund on the other screen, and you can always see the associativity that is being maintained, all the changes or updates that are made live. So it's a dynamic link that you have between all the components. And in terms of the complexity, it definitely can handle very complex assemblies, handle any number of tolerances, any number of objectives. You don't have a restriction unless you have more than 100,000 components. If not, then there is not much of a restriction. So these are some of the basic features inside the program. At least I wanted to give you an overview of all the different features that you have, and so you get a little understanding of how the software works. Any questions? You guys have been quite silent so far, so
I think no questions from here.
no.
So I think it's quite a lot of information. I think. And I think what we have recognized the possibilities of analyzing, optimizing, and especially the connection to this.
I cannot hear you, Bern. You're speaking a little away from the phone.
I think it was a lot of information. Maybe in this level a bit too much. But I think the main points is the connection between solid edge and the software, and the possibilities of analyzing, finding the right dimensions or tolerances where to modify, and all the different possibilities of analyzing. I don't know if Rofin is doing some kind of this analysis today.
I mean, it's not that you have to use every functionality. I'm only showing you what is available in
Yes,
the
yes.
software. So, I mean, not every company uses all the features. I mean, that some might be using just some of the basic worst case RSS techniques. Some might be just using the roll up. I mean, you have all these options available because we just don't do this like uh, just whether to look at this as a stack and then be done. We look at this more of like a process, because if you're doing this, you want to do it right and make sure how to use this information throughout the enterprise and get value from it. Because lot of the times, lot of companies, what they do is they don't get the benefit of doing this activity, and that's why they don't understand the activity and how they can benefit quality, manufacturing, supply chain, engineering, and inspection, and even tooling and fixturing guys.
So
So
my question to the people from Rofin is if this product goes into the right direction, what they are looking for. So that's a question to Mr. Grigoriev and Mr. Shala.
okay, yeah, I mean, I don't know how their work environment is, what they're looking at, but if they have some specific questions on what is it, I mean, how they are planning on using it, then I can try and relate to them more easily.
Also, was Sie sich vorstellen? Also ja, ich glaube schon, dass gewisse Funktionalitäten davon eigentlich uns entgegenkommen. Das heißt, diese reine Toleranzanalyse, eventuell, dass ich mehrere Komponenten nacheinander habe. Das wäre Hello? Can you hear us? Hello?
Hello, yeah, I'm here.
Okay, it was quite loud now. Question to you.
Yes.
What is, from the experience you have made with other companies that want to start using the topic tolerance analysis, what is your recommendation how to get familiar with the topic itself and with SigmundEdge?
Okay.
Any best practices for doing this?
Absolutely. I would suggest doing a simple training on tolerance analysis or tolerance stack-up analysis would be a good start. I mean, it doesn't take much time. It depends on if people have never done a tolerance stack in their life, then you might need a couple of days of training. But if they have done stack-up analysis training, or I mean not training, if they have done some tolerance analysis in the past, then all it takes is a day or 1 day refresher to bring them back.
And then concentrating on one or two kind of analysis types, or what is your recommendation there?
Yeah. One of the things that I would recommend, I mean, do them, Grigor, do you make large volume? What is your production volume? I mean, do you make 1,000 assemblies a year, 10,000, or do you make one assembly? What is, depending on the volume, we have different analysis types. What I would recommend at least is definitely to do these two, worst case and RSS. Those two would be the best two choices, at least to start with. If you're having a larger volume, then probably you're going to look at more Monte Carlo. If you're having a volume of, let's say, 500 or 1,000, whatever, I mean, along those lines, definitely I would recommend that. Most of the companies, I mean, I've been working in this field since last 15 years. I do this every day. And what I would recommend, what we have seen largely that we use, there's a lot of companies use the base worst case RSS. Some use Monte Carlo, depending on the volume of the make. So those are the three that are most prominently used: worst case, RSS, and Monte Carlo. About I should say probably 2/3 of the people use roll up, but after they take a lot of SigmundEdge training, I mean, after they take SigmundEdge training, they are moving towards using roll down. Not many companies use roll down because it's relatively new, a more objective driven design, a more design for Six Sigma.
Hello?
Yes.
It's quite difficult understanding you. So, from what I have understood, is your recommendation was The best idea would be doing some trainings focused on
I'm
this
so,
kind of analysis.
yeah.
Rufin has the best benefit from.
Yes, I'm sorry because of the noise. What I was mentioning earlier is that is correct. Having some training on variation analysis and then using Sigmund to augment that.
Yeah.
And yes, the best approach that I have seen with a lot of our customers is where they have used, majority of them have used worst case, RSS and Monte Carlo.
Yeah. Okay.
And most of them have started with roll up. Roll down is something that they are very new to and they're using it slowly right now. So those would be the optimum situations. And I'm sure every company wants to do optimization. So that is something that is natural. So it's very easy to use. It's not a big deal. It's let's even if we do the if one of us or any of us would do the training for you, I would suggest probably a 3-day class would
Yes.
actually
I think
a 3-day.
from what I have seen, from what I have seen, handling the software, using the software is not a big deal. More, I think the bigger point is to understand the kind of color analysis and so on. I think
You are
the
absolutely correct.
seems so. My opinion, maybe not the opinion from Mr. Grigoriev.
It's okay.
Yeah.
It's really
So we will discuss it here. Yeah.
Absolutely. You are actually correct, Bern. It is using the software is not at all difficult. It is understanding the actual concept of performing variation analysis and then so I mean it's not so difficult. It's a couple of days. I would probably suggest to answer your question directly a 3-day training class with a day of with focus on both the fundamentals and also the software. It wouldn't take more than 3 days. That should actually get the people up to speed. That's what would be ideal situation.
Do you understand me?
Yes. Yes. Yes.
Okay, I'm speaking over the microphone from my laptop.
Oh, okay.
Any
I can hear you.
question?
I have a question concerning where the data are stored. Some data are collected from SolidEdge, and the other informations are stored in files. And what's the type of files? What is they stored in a database? Because I ask this because we have different locations and plans, and we have to store all informations concerning one engineering at a central point, and all our files from SolidEdge are stored in SAP document management system. And concerning to this issue, that's my question.
Okay. Absolutely. And that's not at all a problem. We work with Team Center or with Windchill or any document management system. There are already rules built in, so you don't have to worry about managing. You can freeze to a certain revision level. People can just check in the document. All that Sigmund creates is a SME file. So .sme. So this is that example that we worked on today.
Yes.
And you see that there is a SME file that was created. So all that the user needs to do is to make sure to check that file also into your document management system.
Okay.
And
Is one SME file concerning to one SolidEdge file or to one assembly?
one
Or
assembly.
what's the relation?
There is only you are going to only have one SigmundEdge file, you will not have a SigmundEdge file for each component. So
Only for the assembly.
correct, for the top level or for the top level subassembly. So whatever that is, they can create one file. I mean, I can create multiple files, but it's not going to be of any use. So I want,
Okay,
so ideal
it's
situation is to have one file for each subassembly or for each user. So for example, if one of you is working on one subassembly, because that's how it works in a corporate environment. You don't have one user being having access to the entire subassembly. They own their own subassemblies and they work on their subassemblies. So that would be ideal. You create a SigmundEdge file for each subassembly and then you keep on adding them and you make up the final assembly.
okay. It's just similar to the CFG file where the configuration, the
Correct.
viewing configuration is stored. It's just similar to this.
Correct. Yes.
Okay, and to the inbound of the SigmundEdge in SolidEdge is only install the add-in and activate the add-in, and that's all.
Yes. Go in and say add-ins and you got SigmundEdge. We also have an advanced version, but SigmundEdge is what you just check in this option here. This is our advanced version, but I can just check in SigmundEdge and it shows up in my add-ins. So all that you do is this. You'll see that in even if I open the draft, you still have the same thing. Even if you
Okay.
yeah, whether it is a part or a draft. So this is an individual component or a draft. So I always have that as a simple add-in that we can use. And saving data and modifying it or checking it in, there is nothing different that you're going to do that as opposed to what you're currently doing with SolidEdge.
Okay, but what I see, it's not only at the available at this assembly, it's also available at other SolidEdge documents like draft or part or sheet metal, and the SigmundEdge file belongs always to the SolidEdge file, not only to the assembly.
Yes. For example, here, see, I can export from a part, right?
Okay.
And I can save this. I can go in to a draft. I'm saving it here. I can go into an assembly. Now, in my folder here, I have, no, these are all temporary files, but so I have these 3 files, correct?
Okay.
These 2 files that I just created, I mean, if I open them, there is nothing in it. But why would I want to do this? The user, this doesn't make sense to just import one part and do there's nothing, no studies or nothing can be done here.
It
So
makes no sense.
yeah,
Is it possible to determine the file name? Uh, you're showing the, as you're showing me, the feature a pop-up opens where you can edit the file name, but we have determined file names in our company, and the problem is when, if the user have the possibility to save the file as he wants, there are no rule to collect the file automatically from our DMS system. The best solution would be if the file name from the SME document is still the same as the file name from the assembly or subassembly.
it will be if you open the, see for example here, this is the shim assembly here. This is the assembly, and if I open, export this.
Yes, can you, uh, is it possible without opening this file saving dialog and um, set the file name in dark in the background?
I don't need to open it. Okay, I can just open it directly like this. If you want to open something.
No, when I save,
Yeah,
when,
the
when,
question
when
I
I,
think is what Mr. Schala is asking for is it possible to suppress the save as functionality? The SME file should always have the same name as the solid edge part of the solid edge assembly. Is this was what you meant, Mr.
yes,
Schala?
yes, that's my requirement.
Yeah, that's what you're getting here. This is shim underscore assembly.asm, and this is shim underscore assembly.asm. That's the same one you're getting here. It is the same name.
Yes, it's the same name, but when in this case, I believe open save file dialog is not required because a user can make changes, and I want allowing
Um,
allow the user to make changes.
yeah, but see, let's say I do this study, I open this and create this today, and I want to come back and open it tomorrow. I need to know which one it is, right? So that's why you're getting that option open. When you open it, that's what you're seeing. These are files that have previously created. So
Herr Schaller, ich glaube, Herr Schaller, ich
Ist
glaube,
nebensächlich.
yeah,
primär
you
könnte
can
es,
definitely suppress whatever you want. That's not a problem. Yes, you can. That's not a problem. So to answer your question, yes, definitely.
Okay, thank you.
Yeah, you can, you can suppress and say you can open. We make sure the user cannot change. My environment is different from your environment. In an environment where you have a, where you are launching Solid Edge from a Team Center, or we are launching it from a different software, it works slightly different depending on the environment. So you do have, there are many people that use it with SAP, with Team Center, with Windchill, and other PLM systems. So there's
I believe that that's not a big problem. That's only a small. We will find a solution for this.
yeah, that's not at all. That's nothing to do. That's a very simple thing. So
ja.
any other questions?
Ich bin auf der unteren Level, das heißt, die Datenmanagement, das kenne ich nicht so gut, deswegen habe ich nicht.
I think from here, I think not so far, Mr. Schaller.
No?
Any additional question? Okay. Then, Peter, thank you very much.
Well, thank you, and let me know where you go from here. What are the next steps? And once you get a chance to talk internally, I'll look forward to hearing from you in terms of your plans, how you want to move
We will
forward.
let you know next week. Thank you.
Well, thank you guys, and I do appreciate you taking your time. It was nice talking to you, and you guys have a wonderful weekend.
Thank you very much for the presentation. Wonderful weekend for you too. Bye.
Bye-bye. Thanks, Bernd. Thanks, Gregor. Bye-bye.
Ciao.
Herr Krucker, telefonieren wir jetzt intern nochmal oder wie? Was,
Ja, kann ich ja
Macht
machen.
vielleicht Sinn.
Ich melde dich gleich.
rufen Sie mir an meinem
Ja.
Handy, eigentlich ein Handy an, am besten auf dem Festnetz von der Arbeit. Der Gregor
Okay.
müsste die Durchwahl wissen. 4208.